the band 28 will fall within the lower portion of different services like PPDR, which degraded the service quality. So there might be a problem when LTE transmitter are operating with the adjacent services. So the interference probability is that the large of the channel size band 28 will affect the wide range of adjacent frequencies of different services. So we have a concern on that, since we have yet another services that starts from 806 megahertz. So to finalize or to make it happen, the service under 700 megahertz band, we have cleaned some 700 megahertz spectrum for IMT services. What we did, BTRC revoked the assignment of 706 to 712/734 to 740 megahertz from one of the ISP operators back in 2015. And also we have confirmed that this spectrum is no more used by the ISP through our spectrum monitoring system. And hence we can say that 700 megahertz is ready for IMT services. But we have some remaining spectrum in 1800 megahertz and 2100 megahertz. In 1800 megahertz we have 10.6 megahertz left, and in 2100 megahertz we have 15 megahertz spectrum left. So before releasing the 700 megahertz band, we want to release 1.8 and 2.1 gigahertz spectrum first. That's it from my side. Thank you.
That was all very interesting, and do you have any questions for any of the panelists? Yeah. I believe Arissa Xiong from .com at the back.
Yeah, Arissa Xiong, and my question is really specific to the, we've heard a lot about making the 700 megahertz band available, and how it will be available for IMT and 4G use. But we haven't heard so much about policy objectives from regulators. And in particular, I think we saw some slides earlier comparing the prices of the digital dividend band in Europe and North America versus that in Asia. And we see that in the case of Europe and North America, the prices are slightly higher, whereas in the case of Asia, they're slightly lower. And this, I come back to the question earlier in the day where someone from the floor asked about the motivations of the governments in the region for conducting the switchover and adopting the digital dividend band. Is it purely financially motivated? And if not, what other specific policy objectives are there? Because I think we've seen in some of the specific cases, for instance in the UK and Denmark, where there was a specific policy objective of maintaining mobile market competitiveness in the case of UK and improving broadband coverage in the case of Denmark, that prices of the spectrum in those countries weren't so high. Of course, there are a lot of other reasons behind this, but those were two policy objectives that those two respective governments adopted in their award of the digital dividend. So my question is whether the other countries or the countries in the Asia-Pacific region have similar objectives. What are these policy objectives? And if they could set these policy objectives, if they are not currently already set, what would they be?
Yeah, it's a very good question. I'm afraid, okay, Scott. Well, after Scott, I would like to ask the audience on a policy objectives, or what they have in mind when they think of allocating the 700 megahertz band. But first, Scott.
Thank you. Let me have a go at it. I think we in this room, if you work for a regulator or you work for an operator, I think you've got to accept that there is going to be a legitimate expectation that price will be one of the drivers. I think what's interesting about when you look at the reasons for prices above reserves and all the rest of it is that the countries where you see spectrum go for reasonable prices are those that tend to have much more allocated. So therefore there's less of a scarcity. So I think where the difference is that it's okay to have prices as a reasonable expectation. It shouldn't be the only one. It should be one of 4 or 5. And that as governments and regulators, we need to make sure that there's enough spectrum out there rather than trying to create artificial scarcity. So some of the recent options in Asia, in a way, have been effectively driven by either setting very high reserve prices or by having artificial scarcity. And if we are allocating all of the spectrum that we have committed to at the WRC and the other forums, then prices will tend to be more reasonable, and we'll have to manage that. I think what we have done in certain markets is that governments having an unreal expectation that there'll be continuing price increases and very high option results. And I think we as an industry need to, take government back from that position. So that's a few points. Is it a complete answer? No. I think it's going to be an ongoing dialogue that we'll need to engage in with governments, every government in the region.
Right, so let me ask the audience then. My question would be, do you think that the 700 megahertz band will be key to achieving better coverage in rural areas in the Asia-Pacific region? So please raise your hand if you think that that's sort of on the agenda, that is something that really drives your policy making. So, okay, I think that's your that's your answer, Arisa. So only a few hands were raised here, and I don't know how many are from regulators. Sorry.
Obviously, the ban at being sub-1 gigahertz is great for coverage, and that would seem to be a sensible objective, as is the case that we've seen in Europe, for instance. But it just seems to me that there hasn't been very much explicit views expressed or explicit policies to impose coverage obligations on 700 megahertz licensees, for instance, even in the countries that have already awarded the spectrum in Asia, for instance. So, for instance, in Singapore, one of the policy objectives is obviously that they want to increase competitiveness in the mobile market, so they've gone ahead and reserved some spectrum for a new entrant, even though 700 megahertz was taken out of the lot. That's due to the uncertainty of when the spectrum will be available, but they obviously have a specific objective of something else that they are trying to achieve other than just raising lots and lots of money from auctioning spectrum. So my question is really, what are some of the other objectives that other governments might have? And I take it that achieving better coverage is one of them.
So other potential objectives that you might want to achieve with 700 megahertz band. Well, to my knowledge, I don't think there's a lot of information out there on how this is going to be used. I mean, just mentioned Singapore, who is awarding 700 and 900. Yeah, okay, hit a hard stop there. Just one. So in Singapore, as you mentioned quite rightly, the IDA is trying to bring a new entrant into the market, and they've decided, well, they had the option of using either 700 or 900 spectrum as part of that new entrant spectrum package. They decided to go for 900, which I don't know what what the exact reason behind it is. I think it's the ecosystem is not quite there yet. Potentially that it's not sufficient for a new entrant, and the 900 MHz band is a lot more established. So anyway, Ahmed, if you have time for one more question. Ahmed Nakbal from AIFA.
Actually, your comment just made me think of something. Maybe I could throw a provocative question in. Do you think we'll actually see LT in the 900 band in the Asia Pacific region before we see it in the 700 band in several countries, because of all the reasons that were outlined about it's going to take years and years before we actually have to switch over?
Yeah, we already have, and I think
massive deployment in Indonesia at LT at 900 already. It's already, you know, everyone who, and if you look at Thailand, 850 is being used for coverage as well. I think bottom line is people are looking for sub 1 gigahertz solutions. 900 is perfectly fine for use in that space. Indonesia's one. I think there's some others that are using. I think Telstra is using it in Australia as well for particular events. All up, as I've said in a number of conferences, every band is an LTE band. I actually have a much stronger view of the take-up. I actually think the number of 2G subscriptions will fall because the value that consumers see in a smartphone is very, very high. So if you look at a place like Myanmar, people don't use a normal telephone call. They use Viber, they use WhatsApp, or they use Line and all the rest of it. They actually don't use some of the traditional services. They use OTT. So they then grab those smartphones. Those smartphones work better with an LTE device. And that actually helps out operators because it's lower cost. Architecture is a lot lower, device support, all of those things are a lot lower. So you end up with a virtuous circle.
So just a quick follow-up then. So if revenue raising is important for governments, could you see a situation where one reason why regulators are holding off offering full technology neutrality is because they're looking for opportunities, for example, for allowing 900 to be used for 4G as well as 3G as a means of extracting cash from industry?
Well, by creating artificial scarcity.
Not necessarily deliberately delaying the digital switchover, maybe just as a product of it.
Yeah. Well, that's something that Scott mentioned earlier again as well.
Let me take that one as well. I don't think net neutrality is the driver at all. I think...
Tech neutrality, sorry.
Oh, tech neutrality. No, look, I think... I just think that in a way there's been some restrictions here in Asia on people actually having to either pay a toll or something else to move from 3G to 4G. And yet when you think about it, when we started in this industry, when I started, 3G data was, you know, GPRS or 384. We've gone up to, you know, dual carrier HSPA at 42 megabits, but we never thought that that was a different technology. By calling it LTE, by having a different structure, we've effectively created a bit of a regulatory barrier. So the need for technology neutrality and licensing is absolutely something I support, ITU supports, and I hope most of you in this room do as well, because ultimately we've got a limited amount of spectrum. We want to get the best result for consumers. All up, it's a better, you know, stopping innovation is never a good option.
I think that was a very good summary. So I think, honestly, I haven't had any more questions. I would like to give the stage over to Hein Lazar, who's going to, from the ITU, who is going to give a presentation on intersectoral activities on human exposure to electromagnetic fields. And if the panelists could please say.
Good afternoon. I'm proud to be there. I will be brief, but at least it will take me 15 minutes as outlook and assigned. Intersectoral activities on human exposure to electromagnetic fields. What is the ITU framework on human hazards? There is a plenipotentiary resolution 176, human exposure to and measurement of electromagnetic fields. So the three sectors should follow. IQT question 7.2, strategies and policies concerning human exposure to electromagnetic fields. Last Friday, 24 April, we had the rapporteur meeting in Geneva. ITUT Study Group 5, Environment and Climate Change, question 75. Human exposure to electromagnetic fields due to radio systems and mobile equipment. At this time in Kuala Lumpur there is a meeting, and Friday remote to Kuala Lumpur I contributed our input document. There is an ITUT resolution 72 on measurement concerns related to human exposure to electromagnetic fields, and ITUT resolution on measurements concerns related to human exposure. Some of you can ask, where is ITUR? I hope that at the Radio Assembly of 2019 we'll have also a resolution on human exposure. The author is nominated to represent ITUR Study Group 1, Spectrum Management, Study Group 5, Terrestrial Services, Study Group 6, the Broadcasting, on RF, human, other intersectoral activities. So I represent ITUR at ITUT, and vice versa, all over those ITU. And the Study Group 2 in ITUT, also ITUT, Study Group 5 also asked me to report them what happens at the WHO, the World Human Organization. Those are now, when you get the presentation and you click on the hyperlinks, you get the BS 1698. It is a recommendation around the broadcasting station. Spectrum Monitoring Edition of 2011 refers to how to monitor the RF from base stations, broadcasting and cellular. Strategies and policies, it is a nice report from 2014, question 23.1. It was question 23.1, now it is question 7.2. ITUT technical report, electromagnetic consideration, smart, sustainable. You have it also in your smartphone as an application, an interesting application. And those are the ITUT EMF guide. Unbelievable. A lot of work, many recommendations, many, about guidance on complying with limits, guidance on measurements, mitigation technique, monitoring, evaluating techniques, measurement, a lot of work. Friedrich Levitsky is very active. Now, Kuala Lumpur, they revise those and write new EMF exposure levels in the close proximity of radio communication antennas. So a lot of work is done, and it's done by the best in the West and in the East. We are here. Now, this I got it, you don't see it because it is white on white, World Health Organization. Dr. Van Deventer, she is Department of Public Health at the World Health Organization, and she presented on this Friday 22/4 electromagnetic radio fields, national management and regulatory approaches. What did she say? This is the WHO from last week, Friday. What is written there? Mobile phone use is ubiquitous with an estimated of 4.6. ITUT speaks about 7 billion, but never mind. What is important? To date, no adverse effects have been established from RF fields exposure. So the WHO comes and says nobody died from cellular. Nobody in the world. There are some effects, but no adverse health effects have been established from RF fields exposure. For sure, when you have a microwave in your kitchen and you put your hand, it is very dangerous. But we speak about levels that I will refer next. Studies are ongoing to assess potential long-term effects of wireless technology. This was what we do now. And this is a nice slide that she showed. What do we see here? We see risk assessment, evidence. Is there any evidence? How can we show that there is no risk? We cannot show. Risk management, those are the policies. This is the reason that I'm here, to try to, as an ex-regulator, more than 25 years, how to deal with. And risk perception, it is a psychological problem. Hypersensitivity, electromagnetic hypersensitivity, RF. In Sweden, if you say that you don't like RF fields, they tell you, okay, you are ill and maybe you can get some places with no wireless. So this hypersensitivity is a psychological problem, but we, regulator, we cannot disregard it. If people are afraid, we cannot say that it's your problem, it is the regulator problem. Next, what do we see here? This is the ICNIR 1998, page 59. This is table number 7. What do we see here? We see the frequency range, the electric field all over from 1 to 100 hertz. It is the problem of transformers and electric lines. And then we arrive to the 10 and 400 mega, and we see that there is no power density in the frequencies below 10 mega, because you are in the near field and the magnetic and the electric field are not 120 pi related. But those are the numbers that we see here, and if you remember the 10 watt per meter square, this is above 2 giga, and 2 watt per meter square below 400 mega, and this is the general public, and there is also occupational. This is from my book, widely book reference, levels of occupational general public exposure graphs. You see that the occupational is 5 times more power density than the public, and for sure you are more aware. And there is a directive from 2013 in Europe about occupational, and directive from 1999 about the public exposure. So the lower graph is the 10 mega to more than 100 giga, 300, and the upper is in the lower frequencies. And this is a reference. It is from Excel, but copied from table number 7 of the ICNIR. So this is another, all the figures here are from inputs to ITU. This is an input from Karina Pick from Archiva. They work for the BBC to network their transmitters. And this is the comparison of ICNIR 1998 and 2010. What we see, the 2010 it is till 200 kilohertz, and it doesn't depend on frequency, the field strength. You see the yellow for the public, and the 1998 depends on frequency. So there is discontinuity, and what we say here, this is in our next 1908 guidance includes heating effects for RF above 100 kilo. 2010 guidance includes nervous system effects. So what to do? To ensure protection against both nervous systems and heating, use whichever field strength is the lower. So this is what we write in our ITUT question 7.5, and this is what I propose to you, because there is discontinuity above 100 kilo. And 2010 refers to 10 mega, not only to 100 kilo. This is the figure that we refer. So this is an interesting, very interesting table. Why? You see that United States and Japan, they have power densities 4.4 over 3, so 1.33 higher than the ICNIR levels. Again, United States and Japan. Canada till 2015, February, were the same levels as United States and Japan. So they made studies, and now they are much lower, much lower. Now, ICNIR, IEEE, Australia, New Zealand, the EC directive, all of them, they follow ICNIR. Canada now is much more restricted, and the most restricted is China. China decided 0.4 watt per meter square, which is 8% of the general public power density, and they have different recommendations, one of the health, one of the industry ministry, and they are different, and I put here what is the health number. Now, this was about power density from base stations. More important is the SAR, specific absorption rate. Why it is more important? When you speak with your cellular, those 200 milliwatt that you speak, it is in your head. Now, interesting that United States and Canada, they use 1.6 watt per kilogram and over 1 gram tissue. All world, Australia, ICNIRP, and New Zealand, and China, the 2 watt per kilogram. So if you ask me, it's better to follow the United States view, to be more reluctant on the power density, because no problem, we are far, and all measurements around the world show that the levels are very, very low. But regarding the SAR, be more careful, because when it's written here 1.6 watt per kilogram, it's not that you measure 0.0 watt per kilogram, you measure 0.8, 0.7. So when you buy a cellular, check the SAR. One of the criteria can be the SAR is less. And for sure, the LTE and 3G are 200 milliwatt, and the GSM was 2 watt. 2 watt. Okay. This is another figure from ITUT study group 5, question 75. Calculation on vertical grade. We use the method of moments, and this to estimate what is the power density near point to point. So you see here that 40 meters from the transmitter, there might be a problem if you compare it to the internet level, but no problem, because the link is looking free space. Doesn't look to houses. What looks to houses are the side lobes. So the side lobes in this graph are important, because when you have a point-to-point, it is free looking, but the side lobes in elevation and in azimuth can enter to your room. Okay, this is another calculation from another document. Again, if you click the 679, you will get this nice figure, and you see the main lobe, you see the side lobe. This is from the new ITUT recommendation, exposure levels in the close proximity of the radio communication antennas, and you see the 61 volts per meter, which is the ICNIRP level. This is from another ITUT. This is the report, EMF considerations in smart sustainable cities. We discussed it here in Kuala Lumpur, this report, to revise it, and we see what happened in smart cities. A lot of wireless if we want to have a smart city. And those are some graphs that show cellular safety, that I call it safety that distances in 5D. When we met in Beijing 2 months ago, they didn't like the term safety distances, because safety, let's say those are the distances where the 61 volts per meter of the ICNIR are available. So you see only near the station. But if you go to 1 volt per meter and you see along the street that the levels are higher. So why is it concern of people? Because we heard today from 1,000 subscribers, you have 1 base station. So if we have 8 billion subscribers around the world, we have at least 8 million base stations. So everyone here lives near a base station. If you are in a big city, less than 100 meters from your house, there is a base station. And if you are rural, it is about 300 meters from your house. But everyone here lives near a station. So in many countries like France, do you have the coverage? No. You have where are the field strengths that are higher. Countries like France, they enforce you that schools, hospitals will have lower levels. And we say no. We say all over the same level, because in your house you live more time that you give the children which are in school, but you should be the same. So this is a 2-dimension. This is a 3-dimension, point to point. So you see here the effect of the side lobe of the antenna. Because the side lobe in elevation can go to your rooms, you see the blue. For sure it's not too high, because the side lobe, when you are at the 40 giga, the side lobes are very, very low. Okay, so this is another work done in ITUT study group 5 using the EMF estimator, and you see the distance in a collocated side. And what is interesting, that near the base station the signal is less due to the side lobe attenuation. So those are numbers for FM, TV, and for sure broadcasting is higher. FM, let's say 100 kilowatt ERP or EIRP, or analog TV can arrive to 1 megawatt EIRP. But they are not so popular, or they don't have a million of base stations. So this is from a collocated side. And this is another input to ITU document made in Brazil by Dr. Agostinho Linhares, well known in ITUR, ITUD, ITUT. And you see here measurements that are compared to the Okay. Now, excessive limits affect network planning. I told the Friday in Geneva, remote, that in Geneva it is difficult to get good coverage and capacity because the excessive limits affect network planning. Co-location and MIMO increase the safety distance and restrict mass construction near buildings. Countries like Switzerland reduce by 100 and Salzburg by 900 the power density level and restrict the cellular BTS planning and location, and lower RF exposure and force to decrease the EIRP in order to reduce the power density and field strength, or to extend the distance of the mass from the public. So we have to find that not every city will decide what is the power density of the field strength. Why in city A is different than in city B, and country Japan is different than China? It is the same field strength, it is the same people, we are the same. So why different numbers? So what the WHO and what the ITU says, that we have to adopt the WHO standards which are in the ICNIP 1998. Now, ICNIP 1998 now is revised. And in 2016, WHO said that they will have a new monograph, that ITU is revising it and making a review of it. But I don't believe that the numbers will change, because if they change up, the people will say no. Electrofolks will say no. If it goes down, maybe those who are here, the operators and equipment providers, they can say no. But there is in public of the ICNIP new levels, and we shall have 3 months to respond. Okay, now the first session, why Mr. Hugh Heng, the president of Wireless Marketing Operation, spoke about fiber, that they don't enter enough. My question is not to have more base stations and less fiber optics. My question is broadcasting. Broadcasting can be emitted through cables and through satellites. So the best example was Holland. I asked Holland, why do you need cable terrestrial TV if you have excellent cable and excellent satellite? They told me competition, but there is competition between cable and satellite. So we have to think that not only due to human hazards, but also due to spectrum. So this is about the cable, use satellites, they are cleaner, and for sure, if you want for every village different content, digital TV is excellent. This is the reason that still in Germany they have a lot of digital TV. Many thanks, and I hope that it was interesting, and I will be glad to answer questions.
Thank you very much, Chaim. So, do you have any questions for Chaim? Oh yes, at the back.
Thank you, Mr. Nazar. We have enjoyed a multiple presentation. I'm Tariq Hassan Siddiqui from Bangladesh Telecommunication Regulatory Commission. My question is that we have actually heard about the safety measures. What type of problems might be there because of these BTS numbers? So much BTS numbers are there. Actually, what we hear, we don't know, or we are confused a bit whether this is correct proposition or not. Regarding so many BTS cause cancer, so many BTS cause environmental pollution, etc., etc. Whether this is correct proposition or not, that needs to be 25. So would you please clarify whether this is correct or not? Thank you.
Okay. First, as I said before, I am a doctor but not a physician. So I have to refer to what WHO. To date, no adverse health effects have been established from RF field exposure. Now, for sure, we the engineers, what we do is very simple. We decided the 0.1 degree extent of the temperature of your body is dangerous. We took those numbers, we divided them by 10, and this we said this is for the occupation. Then we divided it by 5, and this is for the general. So we divided by 50 the 0.1 degree. Now all the levels there refer only to temperature. Below 100 kilohertz until even till 10 mega, there is a nervous effect that is covered by the EP3 2010. What I can tell to you is you can use safely everything, but English say as low as reasonably achievable. So if you go to sleep, close your Wi-Fi. Why do you need your Wi-Fi, let's say 100 milliwatt, to operate in Europe and in America 4 watt? Why do you need your Wi-Fi to operate when you go to sleep? So this is the alarm, as low as reasonable achievable. If your house is 15 meters from a base station, maybe it is devaluated. And in our country, operators pay for those who are near the base station. So it's better not to live, let's say, 15 meters. But 20 meters from any base station with about 50 watt EIRP, it is safe according to the ICNIR levels. And as you saw, ICNIR levels are good. The problem is with your cellular. The cellular you hit not only your cellular but also your head. So it's better also, as low as reasonably achievable. Tell your children not to speak more than minutes with their cellular. And this is what the WHO in another paper said. Thank you. Any other question? We have a workshop now by ITU, and we don't want it to be late, but if there is any question.
We're already slightly late, but for those of you who would like to attend the ITU workshop, it's to your left in the next room. Everyone else is more than welcome to join us for drinks on the at the Red Sky Bar upstairs. And even if you're attending, it's not an either or choice. Please join us later. There will still be drinks left by the time the ITU workshop finishes. Thank you very much, everyone.